Dear students, good morning to you. This class for class 9. In last period I have started exercise 2.4. Now question number 1 I have finished. 2 math I have done. Other 2 math you will try. Now I will start question number 2. It is same with question number 1. So page number 43. Page number 43. Question number 2. Here given, use the factor theorem to determine whether gx is a factor of px in each of the following. It is same with question number 1. So, exercise 2.4, question number 2, 1. Here px equal to this polynomial is given and gx is x plus 1. We have to verify whether gx is a factor of px, means x plus 1 is a factor of this polynomial. We have to verify. So it is same with question number 1, means starting part is same. So first we'll find the 0 of this polynomial x plus 1. So here we'll write the 0 of x plus 1 is minus 1. Is clear that 0 of this polynomial is minus 1. Now we will find the value of this polynomial at x equal to minus 1. So p minus 1, so 2 minus 1 whole cube minus 1 whole square, 2 into minus 1 minus 1. So now don't multiply 2 with minus 1. First we find the cube. Minus 1 cube means is minus 1. So 2 into minus 1 is minus 2. Minus 1 square is 1 plus 1, so it is 1. Remove the bracket, minus minus plus 2, and here minus 1. So now we'll simplify this and this cancel, this and this cancel. So remainder is 0. Clear the remainder 0? So then we'll write that gx makes x plus 1. So gx is a factor of px. And if remainder is not 0, then we will write gx is not a factor of px. So his answer is finished. Same with question number 1. First we find the remainder by remainder theorem. Then you say whether gx is a factor of px or not. So start number 2. Question number 2 of 2. Number 2, px is equal to x cube plus 3x square plus 3x plus 1, and gx is equal to x plus 2. Okay, so you write the 0 of x plus 2 is minus 2. Now we'll find the value of this polynomial at x equal to minus 2. So p minus 2. So minus 2 whole cube, 3 into minus 2 whole square, 3 into minus 2 plus 1. So it is minus 8. Minus 2 square is 4. 3 down 4 is 12. Minus 6 and plus 1. So here minus 8, minus 6, minus 40. 12 plus 1 is 13. So it is minus 1. So remainder is minus 1. So it's clear the remainder is not 0. So therefore we will write that gx is not a factor of px. Remainder, it may be plus, it may be minus, it may be fraction. Anyway, but just we say if remainder 0 is factor, remainder not 0, then gx is not a factor of px. So easy. So others that one more math is there. So you will try. I think you can finish this one also. So now we will start question number 3. Question number 3, page number 44. Here given, find the value of k if x minus 1 is a factor of px. Here you see x minus 1 is a factor given. No need to verify. Is given the factor of this following polynomials we have to find the value of k. So it is also some part same with number 1 and number 2. So number 3. Question number 3, 1. So 1, px equal to x square plus x plus k. Here given x minus 1 is a factor of this polynomial. Is given. Then we'll start same with number 1 and 2, means we'll find the 0 of this polynomial. So you write the 0 of x minus 1 is 1. So now we'll find the value of this polynomial at 1. So 1 square plus 1 plus k. So it is 1 plus 1 plus k. That is 2 plus k. This is the value of this polynomial at x equal to 1. Okay, more we cannot simplify. Now here one thing is given, that x minus 1 is a factor of this polynomial. Then whatever the remainder we got, the remainder must be equal to 0 by factor theorem. You have learned the factor theorem. Okay, so since it's factor, so remainder must be equal to 0. So therefore we will write that 2 plus k is equal to 0. Means for some value of k, this term must be equal to 0, means remainder must be equal to 0. Now this is an equation in terms of k. We will solve. Therefore k equal to minus 2. So minus 2, k value is minus 2. This is answer. This is answer. Now one thing is, see, check. If we put this value of minus 2 in place of k, then k value minus 2, then minus 2 plus 2 will be equal to 0. So it's clear, for minus 2, if we put here, the remainder will be 0, because it's a factor. So this way, first we find the remainder, then since factor remainder must be equal to 0, you will get one equation, solve it, you will get the values of k. So it's clear, I think. So I start number 2. Question number 2 of question number 3, it is same. Number 2, px is equal to 2x square plus kx plus root over 2, and the term x minus 1 is same, means it's common for all. So we write the 0 of x minus 1 is 1. So therefore p 1. So 2 1 square k into 1 plus root 2. Simplify 1 square 1, it is 2 plus k plus root 2. Now you see this line. We cannot simplify more. 2 and root 2 we cannot add also, we cannot subtract also. So this is the line we cannot simplify. Then 6 is factor, so remainder must be equal to 0. Therefore 2 plus k plus root 2 is equal to 0. So find the value of k. Therefore k equal to minus 2 and minus root 2. So this is the value of k, means this is the answer. And here clear, if we put the value of k here, then this term will be 0. Means remainder will be 0, because x minus 1 is a factor. So we got the k value. Okay, it's clear. So it is easy. So other 2 math you will try. I think you can solve it. It's easy math. So question number 2. Now means question number 3 is finished. 2 more math is there. You will try at home. Now number 4, factorize. Read the question. Number 4, it is factorize. So students, you see, a polynomial or an algebraic expression, we can factorize different method. But here one method is given, that by splitting the middle term. I think you have learned in class 8. So how to factorize by splitting the middle term? This is very important. Otherwise, sometimes we can use the identity, we can factorize, by taking common we can factorize. But here question number 4, how to factorize using the by the splitting the middle term. This is very important. So we'll start question number 4. Number 1, 12x square minus 7x plus 1. This is clearly a quadratic polynomial. If we factorize, then we will get two linear factors. Here clear, we cannot use any identity. Here no one term is common. So by using identity and taking common, these two methods we cannot factorize. So this term we will factorize by splitting the middle term. But here some rules is there. This rule should be clear. So if we want to factorize by splitting the middle term, first here coefficient of x square is 12. So whatever the coefficient of x square, either 1, 2, 3, 4, 5, any term, then by that coefficient of x square and the constant term you will multiply. So here coefficient of x square is 12 into 1 is, what is the product is 12. So this you have to product it. Now you see the sign of the last term is plus. This is very important. Now we will split 7. We will split 7 by adding, because sign of the last term is plus. If sign of the last term is minus, then we will split this middle term by subtracting. And here since the sign of the last term is plus, so we will split 7 by adding. Now you see 7 can split in this way, 6 plus 1. We can split is 5 plus 2. We can split as 4 plus 3. This 3 way we can split 7. Okay, because 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3 is 7. But you see, here the product of 12 and 1 is 12. Here 6 plus 1 no doubt will get 7. But 6 into 1 is 6. So this 12 should get. So this one, 6 plus 1 we cannot split of 7. Same, 5 plus 2 is 7. But 5 into 2 is 10. But we should get 12. So this also we cannot split. 4 plus 3 is 7. 4 into 3 also 12. So this 4 plus 3 we can split, because both conditions are satisfied. So this you have to verify. Okay, then 12x square minus, then split 7 in bracket 4 plus 3 into x plus 1. Yes, we can write as 3 plus 4 also. But as far as possible, then the greater number you will write first, then second number. Okay, then 4 plus 3 is 7, 4 into 3 that 12. Now 12x square, remove the bracket, plus minus 4x. When remove the bracket, this sign will change, minus 3x plus 1. Okay, now we got the fourth term. It was given 3 terms. Then we have split it middle term into 2 terms. So we got this fourth term. Now from the first 2 terms, we should take some common. Here at least x will be common. Some other term may be common. So here 12 and 4. So the common factor is, greater common factor is 4. Means 4 will be common and x is common. So in total 4x is common. So if we 4x common, then you divide 12 by 4 is 3. And out of 2x, 1x is common, that is x. And here 4x total full term common, so it is 1. Okay, so common is very important. Here no common. If no common, then here 1 will be common. Here since minus sign, so minus. So if no term common, then 1 is common, because 1 is the common factor of all term. So here 3x, but when minus sign is there, this sign will change, here minus 1. Okay, when minus sign, then this sign will change. After taking common, you will verify or check this term and this term should be same. You see here 3x minus 1, here also 3x minus 1. So from this term 3x minus 1 is common. Here remaining terms is 4x. Here remaining terms is minus 1. So we got 2 factor. So this is answer. So this term is factorized and this factorized by splitting the middle term. And these two are both linear factor. So this is answer. Is that clear? So how to factorize by splitting the middle term? Some rules you have to remember. Okay, let's start number 2. I think the conception will be more clear.